Hey everyone, today we'll be talking about lesson 5.6, the fundamental theorem of algebra. And basically what the theorem says is that a polynomial of degree n has exactly n solutions. So if we have a third degree polynomial, it has 3 solutions. A fourth degree polynomial has 4 solutions, etc. And so we want to talk about the forms that those solutions can take. If you will go ahead and pause your video for just a couple minutes and draw these graphs. They don't have to look exactly like mine, but what is important that you have the same number of crossing or touching points that I have. So you want to make sure that you draw your graphs to where you can draw the dots that I have. Come back here as soon as you're done and we will continue. Okay, so let's take a look at this. I want to start with this blue graph here on the quadratic. So we know that a quadratic has a degree of 2, so it should have 2 solutions, and I can physically see 2 solutions. I see 2 dots where it crosses the x-axis, so these would be considered 2 real solutions. I can see them on the graph. The next one I want to look at is the green one, and I only see 1 dot, but remember what we talked about a couple lessons ago, where if we came to the x-axis and bounced off, that meant that we had a repeated solution because we had 2 of the same factors. So this we would go ahead and note as an RS for repeated solution, and it's a bounce. And so we would say that this is 2 real solutions total. Even though I only see 1, I know that because of the bounce, it's actually 2. And then finally, for the pink, it doesn't cross the x-axis at all. So that means that it is 2 imaginary solutions. So in every case, we have to have 2 solutions, but they can be 2 solutions that are different, 2 that are the same, or 2 imaginary. Let's look at the same types of cases over here on the cubic. So cubic, degree of 3, so we have 3 solutions. On the blue one, we can see 3 dots physically on the graph, so that's going to be easily labeled as 3 real solutions. The green, I see 2 dots, but again, one of those bounces right here. So I have a repeated solution, which is a bounce, and I have 1 crossing, where I just cross the x-axis here. So total, we have 3 real solutions. So 3 real total. Finally, on my pink graph, I see 1 solution, so I have 1 real solution, and I must have 2 imaginary solutions. And another thing that I want to kind of notice is with a cubic, I'm always at least going to have 1 solution that's real. Since these arrows go in opposite directions, they cover everything from positive to negative infinity. There's no way to draw a third degree or actually any odd degree polynomial without at least crossing the x-axis once.